Hey guys, today we're going to learn another rule of exponents, the rule of division. So let's get started. So first off, if you remember the rule for multiplication with exponents, we added. So guess what, when we divide, what we're going to do? We're going to subtract. And so here's what it looks like. And then if you look here, you can see it with numbers. So let's get started practicing that. And by the way, this rule is on your formula chart, so you don't have to memorize it. So here we go. So remember, the base has to be the same to apply this rule. That's very important for you to understand. So the first example, the bases are the same. They're both 3. So this would be the same as saying 8 minus 5 for the exponent, which would then make it 3 to the power 3. 3 to the power 3 is 27. Next one. The next one's going to solve a big mystery that a lot of you have had or asked me about. So here we go. If you look at x to the power 15 over x to the power 15, you would know that that's 1. Just because you know that 3 over 3 is 1, 10 over 10 is 1, 1,000 over 1,000 is 1. Any number over itself is 1. But let's also apply the rule for exponents and dividing. So that would mean that I'd go 15 minus 15, which is 0. That's why any number to the power of 0 equals 1. Pretty cool, right? Let's move on. All right, we have a rule from yesterday. We have an exponent, and there's some 2 terms in the parentheses, so we have to distribute this exponent to both terms. So we're going to do that. I'm also going to create one of these little graphic organizers, I guess you could say, I'll call it. So I'm going to put the numbers that were on top. I'm going to divide them up by term, and then I'm going to go ahead and expand the numbers that were the denominator, but I'm also distributed that 4. All right, I have like terms sitting on top of each other. Now I'm going to divide. So 5 minus 4 is 1, so that's a to the power of 1. 9 minus 4 is 5, so that's b to the power of 5. I don't really need the number 1 on the a, so I'm going to take it off. A, b to the power of 5. Bam, there we go. Let's look at the next one. The next one is already all stacked up pretty for us, so we don't have to combine, we don't have to stack like terms. So let's see what's going to happen. I am going to go ahead and put the line. The numbers are going to simplify to 1 over 2. 3 minus 3 is 0. Now I want you to notice that as I'm working on each of these division problems, I'm putting the number on top. 6 minus 5 is 1. 8 minus 3 is 5. All right, I did all the division. Now let's simplify. See what we need to do. So let's see, the x to the power 0 goes away because that's just 1. I don't need the 1 with the y, so I'm going to take it off. And the z can stay where it's at. So I'm going to rewrite this. I don't need the other number 1 either. Now again, if you put those in an answer, it's not wrong. You just don't need to. There you go. Done. All right, I took some of these off to save time. I always try to keep my videos under 15 minutes, so let's move on. The next one is also stacked. So I'm going to go ahead and create my little graphic organizer, or whatever you want to call it. And I'm going to simplify the fraction. The like terms are sitting on top of each other. So 5 minus 3 is 2. The y's, 3 minus 5 is a negative 2. And for the z's, 2 minus 7 is a negative 5. So if I look at this, I can push this down and I can push this down. So I'm going to go ahead and do it. Looks like x to the power of 2 is the only thing that's staying up on top. The 12 is still down at the bottom. I'm pushing down the y's. I'm pushing down the z's. And I am, that's a really horrible 5. I am done. Moving on. How about scientific notation? So scientific notation, I'm going to go ahead and stack them like I've always stacked, how we've been stacking them. I can stack like terms. So instead of This divided by that, I'm going to just go ahead and stack. I'm going to put the 8 times 10 to the power of 5 down here. Now, I almost skipped this one. I mean, I had a choice, the easy one or the hard one. But I'm going to go ahead and go with the hard one because there's an extra step in here I want you to see, just in case you have to do it sometimes on a test or something. Hopefully not. All right, so let's see what we have here. The 2 and the 8 simplify to 1 and 4 times 8 minus 5 is 3. Now, I don't know about you, but I never write anything. I never write scientific notation with a fraction in it, so I'm going to rewrite it as a decimal. 0.25 times 10 to the power of 3. Now, there's something wrong with this because the leading number needs to be between 1 and 10, and right now it's 0.25. That's less than 1. So I'm going to have to move the decimal over. So I'm going to move the decimal over. But if you notice, I'm moving it to the right. The other day, we were moving it to the left. I'm moving it to the right, and that will cause me to subtract 1 from the power of 3. So now I have 2.5 times 10 to the power of 2. And I went ahead and wrote out to the side, this is scientific notation. But sometimes it will ask you to write it in standard notation. And just so you know what that means, it just means just normal. I'm just going to write it as a normal number. So if I worked out 2.5 times 10 to the power of 2, I would get 250. That is how to write it in standard form. And you want to always pay attention. Is it asking you to write it in scientific notation? Is it asking you to write it in standard form? Let's move on. Now we have fractional forms with an exponent, which what you would do in those situations is you would distribute the exponent not only to the numerator, but also to the denominator. And so you can see how that looks in the rule and in the exponent. But practice is what makes it stick. So let's practice it. So I have 2 terms here. So I'm going to distribute this to the top and to the bottom, which is kind of weird for us. So remember, when it's power to the power, we multiply. So 3 times 4 is 12. 2 times 4 is 8. And this becomes, look at my notes here, pretty big. It becomes 4,096 over 6,561. Next one, I have 1, 2, 3, 4 terms I have to distribute this out to. So we have a to the power of 4, b to the power of 16, c to the power of 8, d to the power of 12. None of these terms are like terms, and none of them have negatives, so I'm done. Let's look at the next one. I have to distribute this to the 6, to the x, and to the y. Whoops. X and to the y. I have to distribute it to the 4, to the x down here, and to the y. So I have to distribute it to each term within the parentheses. So this is 6 to the power of 2, x to the power of 8, y to the power of 2, 4 to the power of 2, x to the power of 4, y to the power of 4. All right. 6 to the power of 2 is 36. 4 to the power of 2 is 16. Let's look at those x's. 8 minus 4 is 8 to the power of 4. 2 minus 4 is y to the power of negative 2. So this will get pushed down. I'm going to simplify the 36 and the 16, and they become 9 over 4. The x to the 4 gets to stay on top. The y squared must be pushed down to the bottom. Next one. What happens if the exponent is negative? When the exponent is negative, you will flip the entire fraction. But when you flip the entire fraction, don't change the signs of the exponents. And I put a special note here on the side. You can copy that down when you pause it or whatever. But just so you know, so when I flip it, you're going to notice I don't do this. So it's a -3. Now I'm going to go ahead and flip the whole thing and then change the negative to a positive, and then we can do what we've been doing already. So first thing, 3 squared over 4. Now it's a +3 because I flipped it. That's the only new thing that we just did. Okay, so again, I have a term here and I have a term here. So this is now 3 to the power of 6, 4 to the power of 3. My messy handwriting, 729 over 64. Next one. Now you could distribute this negative to each term. But what's going to happen is they're all going to become negative and you'll end up flipping them all anyway. But just so you know, you could if you wanted to do that. I'm going to go ahead and flip the whole thing and then change this to a positive. But I have to distribute it. I have to distribute it here, 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 and here. There's 4 terms there. So that becomes b to the power of 8, c to the power of 12, 2 to the power of 4, a to the power of 4. Now there's nothing that I need to stack on top of each other, but I do have 2 to the power of 4, and I'm not allowed to leave it that way. So I'm going to work that out. So it's b to the power of 8, c to the power of 12, 16, a to the power of 4. So don't forget, if you have a number, you have to get rid of that exponent by working it out. Last one. It's a lot. So let's move quickly. You know, I have to get this done in less than 15 minutes. So I'm going to flip it. 4x to the power of 3y squared over 2x to the power of 5y to the power of 3. And instead of a -3 now, it's a +3 because I flipped the entire thing within the parentheses. But remember, I'm not done yet. I have to distribute that 3 to 1, 2, 3, 4, 6 different terms. So let's do it. We have 4 to the power of 3, x to the power of 9, y to the power of 6. That's the numerator. 2 to the power of 3, x to the power of 15, y to the power of 9. That's my denominator. They're stacked like terms, so let's work everything out. And as far as the numbers go, I have 64 over 8. I have 9 minus 5, so I have x to the power of -6. I have 6 minus 9 for the y's. That's y to the power of -3. This is going to get pushed down. This is going to get pushed down, and the numbers need to be simplified. 64 divided by 8 is 8. That is the only thing left on top. The x got pushed down. The y got pushed down. We are done. Now, please feel free to work through this again. I talked kind of fast. Please pause as you go, and don't hesitate to listen to it again. Ask for help if you need it. I'll see you later. Bye-bye.